Hello again and good morning. This is Flash Talk number 3 on AI Ontology for Health and Data Sciences. This is Dr. Adam Pace. Glad to have you back, Dr. Adam Pace.
Thank you. Glad to be here.
Great. So today we're going to continue our discussion from last time and go further into the depths of ontology and perhaps define it better, right? So what is an ontology? Would you like to talk about it?
Yeah, that's a great way to start. So my definition of ontology is essentially it's a dictionary for computers to read. So it has a lot of concepts, and those concepts are defined. But the key to differentiate an ontology from a human readable dictionary is that the definitions are in a computable language. They're in a particular mathematical language that the computer can understand. And as I talked about in our last session, there are really these two requirements. Your language in which you state the definitions has to be very expressive. You have to be able to say everything you want to say, and you've got to have said a lot of things so you're not writing the dictionary from scratch yourself. There's got to be your big reusable library, and that's what we have.
Great, great. Would you like to give an example with a medical, scenario or doctor?
Yeah, let's go on to I think we've got another slide here that gives you some background. Yeah, what does this look like in practice? Well, like a lot of things that are called ontologies or taxonomies, there is a big taxonomy. So we have notions of what is a profession. Professions include medical doctors. A kind of medical doctor is a surgeon. We have relationships, for example, that professions are disjoint from occupational trades like plumbers or carpenters. We have a lot of linguistic information, such as the translation of medical doctor into Chinese, or Bihishang, and you can see the Chinese simplified characters there as well. And we've got a whole bunch of other languages. So it's just an illustration of some little bits of things here to be very concrete. And we've also got definitions. Not only do we have things like the English definition of a medical doctor in the Sumo Ontology, and associated things like the notion of a medical service here, where we're relating these two notions. A medical service employs a medical doctor that conducts a therapeutic or diagnostic process. And each of these nouns, as well as verbs and other relationships, are already in this big dictionary, already defined for you. So let's look a little bit at what one of these math definitions looks like. If we can move on to the next slide, there we go. Yeah, so obviously I'm not going to expect everybody to be able to read all this, but just to get very concrete, here is how we express this notion that a medical service employs a medical doctor, conducts a therapeutic or diagnostic process. And unlike the English definition on top, the code below is something that a computer can understand at a certain level. It can manipulate. It has a formal method for reaching new conclusions based on this data. And that's what we spent so long trying to create, this reusable library of a lot of code that's really just like the Java or the Python libraries, but in a declarative language that states definitions as opposed to procedures for what to do.
Great. I believe this also can help us, inculcate the philosophy of responsible AI, ethical AI, because, it's all described in one place and everybody has a right and transparent view of things. They can look at it and they can define it even better as a group. So I really like this example of how things are broken down. And I believe same can be done for viruses, coronaviruses, and all the other variants of the same novel coronavirus. So what are the benefits? Let's talk about the benefits today to the health group here.
Yeah, so the benefits, even beyond what I've listed here, I mean, you were just starting to talk about transparency. And so this whole notion of explainable AI and responsible AI is really important. If you just have a lot of sort of statistical data, it'd certainly be a challenge to explain, well, why did the machine choose to do one thing or another? If you've got computable definitions, you've got all this stuff very explicit and concise that explains why a machine made a particular decision or not, and what its assumptions were. So if you're involved in having to deliver a medical system, it's going to be key to have the system be able to document and explain Why did it make the choices that it did? And so this technology gives you a way to do that. So we spent the last 2 decades creating this very large library called SUMO, the Suggested Upper Merged Ontology, that it has about 20,000 terms, about 80,000 statements that have been defined in this expressive language written by hand, just like any other computer program. Um, but also we've got links to very large fact databases that are just millions and millions of different facts. So a lot of resources. I mentioned this notion of different lexicons. So we separate the formal math from the labels we put on things in different languages. So this should be obvious to any multilingual speaker like yourself, Viru, that concepts are expressed differently in different languages. And yet a lot of computer science, we've been relying on translation on the fly. I don't think that's really sufficient in the long run. And we've got all these resources that if we have a language independent way to state and define things, as we now do with Sumo, we can then link in all these dictionaries so we don't have to do translation on the fly, and we can verify these things to a very high level of fidelity by humans. So this translation doesn't have to be done again and again and again automatically. So a very important resource. And then lastly, we've got a big tool set. So in the same way that modern programming languages have resources like Microsoft Visual Studio or IntelliJ or Eclipse, we also have a whole development environment that's all open source that makes it a bit easier to develop this stuff.
And I believe a lot of users around the world are currently using this and probably figuring out cool new ways of, kind of connecting the two worlds, right? The perception oriented and the logical and the symbolic version of AI all together with machine learning and um, ontology coming together. So thank you for your explanation and time today. Next time I believe we'll go deeper into practice and the use of ontology, right, in a specific method that you can follow and uh, prove the use of ontology. Thank you for your time. Appreciate it, Dr. Adam.
Yeah, it sounds great. Looking forward to more.
Great. Thank you.